Our objectives of this integrative activity are to distinguish the different types of hydrocarbons, recognizing its proper characteristics. Also are to explain how to name and draw the structural formulas of the different hydrocarbons.
As an introduction, the International Unit of Pure and Applied Chemistry, IPAC, serves to advance the worldwide aspects of the chemical sciences and to contribute to the application of chemistry in the service of mankind. As a scientific, international, non-governmental, and objective body, IPAC can address many global issues involving the chemical sciences. IPAC was formed in 1919 by chemists from industry and academia. Over nearly 8 decades, the Union has succeeded in fostering worldwide communications in the chemical sciences and uniting academics, industrial and public sector chemistry in a common language. IPAC has long been recognized as a world authority on chemical nomenclature, terminology, standardized methods for measurement, atomic weights, and many other critical evaluated data. A rational nomenclature system should do at least 2 things. First, it should indicate how the carbon atoms of a given compound are bonded together, and a characteristic lattice of chains and rings. Second, it should identify and locate any functional groups present in the compound. Since hydrogen is such a common component of organic compounds, its amount and location can be assumed from the valency of carbon and need not to be specified in most cases. The IPAC nomenclature system is a set of logical rules devised and used by organic chemists to circumvent problems caused by arbitrary nomenclature. Knowing these rules and given a structural formula, one should be able to write a unique name for every distinct compound.
Hydrocarbons are the simplest organic compound, containing only carbon and nitrogen. Hydrocarbons are separated in saturated and unsaturated. Alkenes that contain only single bonds are deuterated, and alkenes, alkynes, and aromatics are unsaturated. Alkenes contain double bonds, alkynes triple bonds, and aromatics contain the benzene ring.
I'm gonna explain about the alkanes. The alkanes are saturated hydrocarbons that each carbon is bonded to other three. That's why they are called saturated. The formula of the alkanes is CnH2n plus 2, and they are only formed by single bonds. The names are derived from the Greek or Latin name for the number of carbon atoms and the suffix "-n". Well, the IPAC rules to name an alkane. First, we have to count the number of carbon atoms and find the longest chain. Second, we need to number it by selecting the end that is closest to a substituent group. The third step is name each alkyl group substituent by placing the name of the group before the name of the parent chain. The fourth step is if same alkyl group occurs more than one, we need to add a prefix like D if it is 2 times, or 3 if it is 3 times, etc. The fifth step is when different alkyl groups are attacked to the same parent structure, place their name in alphabetical order. Like if you have a methyl and an ethyl, first you place the ethyl because of the alphabet. And the last step is to write the entire name of the example of the alkane, and using hyphens to separate numbers from words and commas to separate numbers. Well, now I'm going to explain a problem about the alkane. First of all, we need to identify which is the longest chain, and we need to start by the CH3. Anyway, in this case, the longest chain is this. Second, we need to number them by selecting the end that is closest to a substituent, and in this case is this one. This one is called a methyl because it only has one, and this one is called ethyl because it has two. Then we need to number these alkane. How? Well, as I said in the rules, we need to play them by alphabetical order. And in this case, it's 3. That means that is in the number 3. Ethyl. That is this one. And then we use the number 2 to represent that is in the second carbon, and then methyl. And after this, we need to add the number of carbons with that is hexane, because there are 6 of them. Now, I'm gonna explain how to solve a problem if they give us the name but not the draw. First, we need to focus on the last part of the name, because that tells us how many carbons the longest chains have. In this case, hexane, that means 6. Here, we draw the first only carbons because we don't know how many hydrogens they have yet. Then, fourth, ethyl to dimethyl. That means 2 and 2. So we're gonna start in the left. 2 dimethyl is 1. Dimethyl, that means they have 2 methyl, and the methyl it only has 1 carbon. So, for ethyl, 1, 2, 3, 4, ethyl, 2 carbons. That will complete the drawing of this, but remember to complete the carbons of the drawing. 1, 2, 3. And that's how you draw the problem if they just give you the name. Only one line because there's only single bonds.
Now for naming alkenes, it's pretty much the same as alkenes, but instead of naming these carbons with the term "ane" at the end, we have to change it to "ene." And to name alkenes with 4 or more carbons in the chain, it is necessary to specify the location of the double bond. This is done by numbering the carbons in the branch chain that are nearer to the double bond. Cyclic alkenes are named in much the same way as cyclic alkenes. However, carbon number 1 must be one of the carbons connected by the double bond. And as I told you, to name alkenes is pretty much as alkenes. So let's follow the first step, that is engulf the longest chain. In this case, we have to engulf the longest chain that contains the double bond. So here, the longest chain is this one. Now we have to name each carbon starting from the end that is nearer to the double bond. Here is 1, 3. Now, since this is the unique substituent, we have to name it. And because it only has 1 carbon, it will be named methyl. So because it is in the number 2, we have to write 2 hyphen, because it is to separate from numbers to letters, then methyl. And finally, because it has 4 numbers, it is good, and instead of "ane," it will be "ene." Now, when they give us the structural formula and they request us to write the name of this proper alkene, we have to follow this single step. First, we will number the carbons that are in the longest chain. In this case, is this one. We will start from the carbon that is nearer to the double bond. This is 1, 2, 3, 4, and 5. So here we have a substituent, and since they are 2 carbons, it will be named ethyl. And it's in the number 2, so it will be 2 ethyl. And we have to say where is the double bond, and we have to choose the simplest number. So between 2 and 1, the simplest number is 1. 1 hyphen, and this longest chain has 5 numbers, so it will be pen.
Now we're going to define what they are alkenes. Alkenes are unsaturated hydrocarbons with at least one triple bond, and the general formula for alkenes is CnH2n-2. So now we're going to identify the structural formula for alkenes. First, we need to identify the longest parent chain, which in case is this one, and it has to include one triple bond. So the next step is to number them. This is 1, 2, 3, 4, 5, 6, and 7. The next step is to identify the substituents, which is this one, and is ethyl. And then we need to identify the number with which ethyl is connected to, which is 4. So we need to put 4 ethyl. And then as there are 7, we need to put and the easy or the closest number to the triple bond is 2, so we need to put 2 and 2 and 10.
We have aromatic compounds that are organic compounds that contain benzene rings as a part of their structure. Six-sided structure with single and double oil bonds. We have some examples of aromatic compounds with only one substituent, and if you want to name them, you just have to look like at the substituent they have like outside of the benzene ring, and just know like this is chlorine, and you just name it chlorobenzene, and this that is an ethyl, you just name it ethylbenzene. Now, when you have two substituents like chlorine and nitrogen, you can name it by using the other way I told you before, or by putting prefixes. For example, you can put ortho when the substituents are in location 1 and 2, meta when the substituents are in 1 and 3, or para when they are in 1 and 4. And these, the name is ortho, and you abbreviate with an O because they are in 1 and 2, and then the name of the first substituent, that is chloro, and then the second substituent, that is nitrogen, so the name is O chloronitrobenzene.
Second question, we now know that there are 5 different types of organic compounds: alkanes, alkenes, alkynes, cyclic and aromatic compounds, and each one has different rules by the effect, which is the organization in charge of addressing many global issues involving the chemical science. We also know how to identify and name each organic compound, and finally, what is a functional group and their formulas.
It's the dream.